Hello and welcome to the solution video to my 2024 Edexcel practice paper 2. Before watching this video, I'd encourage you to read the disclaimer that's on the front of the paper. I've put a lot of effort into analysing the past papers and of course what topics already came up in paper 1, but this offers no guarantees at all. There are many topics that I couldn't fit into this paper that may well appear, so I'd remind you to revise all topics as technically anything could still be asked. It is definitely best to try the paper before watching this video. You can find a link to the paper in this video's description. And now let's have a look at the solutions to the questions. So for question 1, we need to write 90% as a fraction. To write any percentage as a fraction, you just write it over 100. So we need to do 90 over 100. This fraction will simplify, you can divide them both by 10. So if we do 90 divided by 10, we get 9, and 100 divided by 10 is 10. This one's now simplified, so the answer we're after is 9 over 10. You could also just put 90 over 100 into your calculator and then press equals, and it will probably show you 9 over 10. In question 2, we need to write down 3 different multiples of 12. Multiples are numbers that are in that numbers times table, so we just need to write down 3 numbers in the 12 times table. It makes sense to use the first 3 numbers, so 1 times 12, which is 12, 2 times 12, which is 24, and 3 times 12, which is 36. But you could technically use any number that's in the 12 times table. For question 3, we need to convert 3.2 litres into millilitres. You should know that 1 litre is the same as 1000 millilitres. Since we have 3.2 litres here, we need to multiply 3.2 by 1000. You can use your calculator to do this, and the answer is 3200. In question 4, we need to work out 25% of 120. There are a couple of ways you could do this. One way is to turn 25% into a decimal multiplier. To do this, you divide it by 100. 25 divided by 100 using your calculator gives you 0.25. You can then multiply this by the number in the question. So 0.25 multiplied by 120 gives you the answer 30, and that's the answer to the question. You may also know that 25% is the same as 1/4, so you could do 120 divided by 4. For this question, we need to write down the square number that's closest to 200. We get square numbers by multiplying a number by itself. For example, 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. But these are nowhere near to 200. So let's start with some quite big numbers. 10 squared will be 10 times 10, which is 100. 11 squared is 11 times 11, 121. 12 squared is 12 times 12, 144. 13 squared is 169, 14 squared is 196, and 15 squared is 225. So we've now gone past 200, so one of these must be our answer. 196 is very close to 200, it's only 4 away, so that's the answer to this question. It's worth remembering that you have a calculator for this question, and it can do all of those calculations for you. In this question, we need to write down the names of 2 shapes. First of all, we have this quadrilateral, and we're told that all of the sides are the same length. The name of this shape is a rhombus, and certainly not a diamond. In part B, we need to name this shape, and this one is a square-based pyramid. In this question, we need to solve the equation n over 5 equals 20. This over 5 here means divide by 5. To solve an equation, we need to do the inverse operation. The inverse of dividing by 5 is multiplying by 5. So we will multiply both sides by 5. So if we write this equal sign down, on the left-hand side, if we multiply by 5, that'll cancel the divide 5 that's already there, so we're just left with n. On the right-hand side, 20 multiplied by 5 is 100. So the answer is n equals 100. In the first part of this question, we need to multiply 5 by y by y. Let's start by doing y multiplied by y. When you multiply y by itself, you get y squared. Then we have 5 multiplied by y squared, and when we multiply a number by a letter in algebra, we just remove the multiply sign. So this is just 5y squared, and that's the answer to this question. In part B, we need to start with 9a subtract 1a. 9a subtract 1a is 8a. And then we need to divide this by 2. That's just like doing half of it, and half of 8a is 4a. In part C of this question, we need to simplify. To do this, we're going to collect together like terms. We've got 6x squared, subtract 2x squared, and 6 subtract 2 is 4, so that's 4x squared, and for the numbers we have a positive 8, and then subtract 9. 8 subtract 9 is negative 1, remember you can use your calculator if you find that tricky, so we have 4x squared, subtract 1. In this question, we need to fill in the boxes to complete the term-to-term rule. The term-to-term rule says we multiply the previous term by a number, and then subtract another number, and then we end up at the next term. So to get from 2 to 5, we need to multiply by something, and then subtract something. Now there's lots of possible ways that you could do this, but the one that's going to work for all of the terms in the sequence is multiply by 3, and then subtract 1. You might want to use your calculator to test this out on a few terms. So if you start with 2 and multiply it by 3, you get 6, and then if you subtract 1, you get 5. But this also works going from 5 to 14. If you multiply 5 by 3, you get 15, and then subtract 1, you get 14. And if we do this from 14, 14 times 3 is 42, and subtract 1 is 41. In part B of the question, we need to find the fifth term of the sequence, so we'll just continue with this rule. We'll start with 41 and multiply by 3. Remember, use your calculator for this, and you should get 123. And then we subtract 1 from this, and 123 subtract 1 is 122. So the answer is 122. In the first part of this question, we're interested in the probability that this spinner lands on an odd number. Odd numbers are 1, 3, 5, 7, 9, 11, 13, and so on. So looking at this spinner, these numbers are odd. Then we need to look at the probability scale. This one is in 6 equal sections. So the first section will be 1/6, then 2/6, then it's 3/6, which is the same as 1/2, 4/6, and 5/6. Since 5 of these sections were shaded in, the probability is 5/6, so we can mark the cross correctly at 5/6. For part B of the question, we're looking for the probability that we get a factor of 12. Factors of 12 are the numbers that divide into 12 without a remainder. For example, 1, 2, 3, 4, 6, and 12. So let's see how many of these are on the spinner. We can see that we've got 1, 3, and 6. So we've got 3 factors of 12, so the probability is 3/6. So let's put the numbers back onto the probability scale, and 3/6 is right in the middle, at 1/2. In part C of the question, we're told a spinner is spun 900 times, and we need to estimate how many times it's going to land on a number 9. Looking at the spinner, the number 9 is in 2 of the sections, so the probability of spinning a 9 is 2/6. Since it's being spun 900 times, we can just do 2/6 of 900, which we can do by multiplying 2/6 by 900. You can type this exactly as it is here into your calculator, and it'll give you the answer 300, which is the answer to the question. In this question, we're told that 300 grams of sweets cost £3.30, and we need to work out the cost of 3/4 of a kilogram of sweets. 1 kilogram is the same as 1,000 grams, so 3/4 of a kilogram is the same as 3/4 of 1,000. To work this out, you could type 3/4 times 1,000 into your calculator, and it'll give you 750 grams. So where it says 3/4 of 1 kilogram, that's just another way of saying 750 grams. So we know that 300 grams cost £3.30. If we divide this by 2, that'll give us the cost of 150 grams. Dividing £3.30 by 2 gives you £1.65. We can now work out 750 grams by doing 300 grams plus 300 grams, which would be 600 grams, and then adding another 150, which will give us 750 grams. The cost of 300 was £3.30, the cost of the second 300 is also £3.30, and the cost of 150 is the £1.65 that we worked out. So we can just add these up on the calculator, and we get the answer £8.25, which is the answer to the question. In this question, Joshua runs a marathon in 3¼ hours. He then spends 45 minutes walking home after the marathon, and we need to write down the ratio of the time that he spent running the marathon to the time he spent walking home. So the time he spent running was 3¼ hours, and the time he spent walking home was 45 minutes, so we just write those in a ratio. But the problem here is one of these is in hours and one's in minutes. Let's convert the 3¼ hours into minutes. There are 60 minutes in 1 hour. So in 3 hours, there are 60 times 3 minutes, which is 180. A quarter of an hour is 15 minutes, so if we add 15 more, we get 195. So 3¼ hours is the same as 195 minutes. So we can write this as a ratio 195 to 45. We now need to give this in its simplest form. We can do this by dividing both of these by 5. Remember, use your calculator and you'll get 39, and 45 divided by 5 will give you 9. These can also divide by 3, 39 divided by 3 is 13, and 9 divided by 3 is 3. This is now in simplest form, so the answer is 13 to 3. Now, since you have a calculator for this paper, you can do this in another way. If you look at these numbers here and just type them in as a division, 195 divided by 45. Now, some calculators will give you a fraction here, and some may give you this decimal. If you use the SD button to turn the decimal into a fraction, or on a newer calculator you may need to change the format into a fraction, you'll get this fraction here. You should recognise those numbers from our answer, 13 to 3. In this question, we're told that Louise has measured these two angles. We're going to start by marking them onto this diagram. Angle ADB means we start at A and go to D, and then go to B. So this is the angle ADB, and Louise measured that at 32 degrees. Then we've got angle BAD, so we start at B, we go to A, then we go to D. So it's this angle at the top, and that is 81 degrees according to Louise. In the question, we are asked to use Louise's measurements to work out the size of angle CBD, which is this angle here. We're going to do this by working out this angle first instead. We can find that one because the angles in a triangle must add to make 180, and we already know two of the angles. So if we add together the two we already know, 32 and 81 makes 113. We can find the remaining angle by subtracting this from 180, which gives you 67 degrees. So the red one is 67 degrees. We can now find the purple angle, angle CBD, the one we need for this question, because this angle and this angle are on a straight line, so they add up to 180 as well. So we can subtract 67 from 180, and we get 113. So the answer to this question is 113. In part B of the question, we find out that one of Louise's measurements, angle ADB, was actually higher than the true size for the angle, but angle BAD was found to be accurate. We need to decide whether the true size of angle CBD is higher or lower than the answer that we got in part A, and give a reason for the answer. So we're told that Louise has measured angle ADB higher than the true size of the angle. The angle we're talking about is this one here. So if Louise has measured it higher than the true size is actually slightly lower. So let's imagine, for example, it was 31. What would that do to our answer to the previous part? Well, if this angle decreased by 1 degree, when we found out this angle, it would actually need to be 1 degree higher, since those still need to add up to make 180 degrees in a triangle. Then if that angle was 1 degree higher, the final answer would need to be 1 degree lower, since those two angles would still need to make 180 because they're on a straight line. Then we just need to give our reasons on the answer, so we could say that if angle ADB is lower, then angle DBA is higher, and if angle DBA is higher, then angle CBD is lower. So our answer is that the true size of angle CBD is lower. In the first part of this question, we need to convert 40 litres into gallons. We can see that litres is on the bottom axis and 40 litres is here. If we draw a line up to the line in the question, and then horizontally across, we can find out how many gallons it is. Let's zoom in a little bit onto this diagram. Some students may think that each one square represents 0.1, but actually in this one it's 0.2, because it goes 8.2, 8.4, 8.6, 8.8. So the answer to part A is 8.8. For part B, we need to convert gallons into litres, 1,800 gallons. If you have a look at the axis for gallons, we don't have 1,800, it only goes up to 14. To do a question like this, we want to choose a number that divides into 1,800. There are many different ways you could do this question, but I'm going to go for 10. So I'm going to convert 10 gallons into litres. If we zoom in on the axis here, we can see the answer is somewhere between 40 and 50. Halfway in between those will be 45, that's here, and in fact each one square represents one unit this time, so this one will be 46. The line that I've drawn goes halfway in between those squares, so 45.5. So I found out that 10 gallons is equal to 45.5 litres. But we need to do 1,800 gallons. So I need to see how many times greater 1,800 is than 10. You can do this by doing 1,800 divided by 10, which gives you 180. So it's 180 times greater. So all I need to do is 45.5 litres multiplied by 180, and I get the answer, 8,190. Your answer to this question will depend somewhat on where you draw your line. As long as you get an answer somewhere near to 8,200, you'll probably be okay. In this question, we need to show clearly that the area of the circle is greater than the area of the triangle. Let's start by working out the area of the triangle. We do this by doing 1/2 multiplied by the base, which is 25, multiplied by the height, which is 16. You can type this straight into your calculator and you get the answer 200. For the area of the circle, we use the formula pi r squared. So pi multiplied by the radius squared, and you can see the radius of this circle is 8, so multiplied by 8 squared. If you type this into your calculator, you get this as the answer. So we need to show the area of the circle is greater than the area of the triangle, so we might just state that 201.0619298 is greater than 200. In this question, we need to type something into the calculator. So let's take the calculator, and we're going to begin by pressing the fraction button. That's this one here. Then on the top, we have 3.08, and we need to do this to the power 3, so we press this button here, and then a power 3. Then we press the right arrow to get away from this power, and then subtract, and we need to do pi. So pi is on shift, and then the button 7. If you have an older style calculator, it may be at the bottom of your calculator. Then we go down and press the square root for 22, and really importantly, right arrow to get out of that square root, and then subtract 3. Then we can press execute or equals depending on your calculator, and we get this answer here. This question says to write down all of the figures on your display, so you must write down the whole thing, 15.4260981. In part B of the question, we need to round the answer from the previous part to 4 significant figures. So if we take this number here, 4 significant figures means we're interested in the first 4 of these digits. So the 1, 5, 4, and the 2. So we draw a line here, and we do need to just check to see if we need to round up. The number after this line is a 6, which means we do need to round up because that's 5 or greater. So the 2 is actually going to round up to a 3. So it's 15.43. In the first part of this question, we need to factorize, which means we need to put it into brackets. We do this by looking at the highest common factor of all of the terms. Looking at the terms, we've got 8h subtract 12. The highest common factor of these is 4. So we can take a 4 outside of the brackets. Then we need to decide what to put inside the brackets. I like to do this by imagining I expand them. What would I multiply 4 by to end up with 8h? Well, I need to multiply it by 2h, since 4 times 2h is 8h. And what would I multiply 4 by to get to negative 12? This would be negative 3. In the second part of this question, we need to make m the subject of this formula. At the moment, the subject is p, since it's the letter that's on its own. So we want m to be on its own, but at the moment there's a k on the left-hand side. So we're going to subtract k from both sides. If we subtract k from the left-hand side, the k's will cancel, so we've just got m. If we subtract k from the right-hand side, well, we've already got a p there, and we've subtracted k from it, so that's p subtract k. You can see that m is now the subject since it's on its own, so this is the answer, m equals p minus k. In part C of the question, we need to find the value of g when u is negative 12 and d is negative 3. To do this, we're going to copy out the formula, g equals u squared subtract d, but we're going to replace the u with a negative 12 and replace the d with a negative 3. So g equals u squared, but we said that u is negative 12, so negative 12 squared. And notice I've put this in brackets because it's a negative number. That is really important for when we type this into the calculator in a moment. Then it's subtract d, which is also a negative number, so negative 3 in brackets. You can now just type this exactly as it is into your calculator and you'll get the answer, 147. In the first part of this question, we need to measure the real distance between two towns, and we've been told about the scale on the map. It's 1 centimetre represents 5.5 kilometres. So if you take a ruler and measure the distance between the two towns, you should see that it's 6 centimetres. You may get a slightly different answer to this depending on how your page has been printed. If you do print it on full scale A4 paper, it will be exactly 6 centimetres. Now we need to make use of the scale. Each 1 centimetre on the map represents 5.5 kilometres in real life. Since we've got 6 centimetres, we need to multiply 5.5 by 6. Use your calculator to do this and you get the answer 33. In the second part of the question, we need to find the bearing of Mossley from Norton. To do this, we imagine that we are stood at Norton. We face north and we turn clockwise until we face Mossley, which would mean we've turned through this angle here. So we just need to measure the size of this angle and give it as a bearing. To do this, we take a protractor and place it like this with the 0 lined up with north. We then read around the outside scale until we get to Mossley, which we can see is at 82 degrees, 2 little lines past 80. So this angle here is 82 degrees. But there's a rule with bearings that they must always be given as 3 figures. 82 only has 2 figures, so we place a 0 in front. So the answer is 082. In this question, we're asked to expand and simplify. We're going to do the expanding part first. So if we look at the first bracket, we need to do 10 multiplied by n, which is 10n, and then 10 multiplied by 6, which is plus 60. Then onto the second bracket, it's negative 2 times n, which is negative 2n, and then really importantly, negative 2 times negative 5. When you multiply two negatives together, you get a positive, so we actually want to write down plus 10. It's very common for students to make a mistake and put negative 10 here. Now we need to do the simplifying part. We can collect together the like terms. We've got 10n subtract 2n. 10n subtract 2n is 8n, and then we've also got 60 plus 10, and 60 plus 10 is 70. So it's 8n plus 70. In this question, we need to convert 8.1 times 10 to the power negative 3 into an ordinary number. To do this, we're going to start with 8.1, and because it's a negative power of 10, we're going to divide it by 10 3 times. If we divide it by 10 once, we get 0.81, a second time 0.081, and a third time 0.0081. So the answer is 0.0081. For part B of the question, we need to write 419,000 in standard form. For a number in standard form, the first part must be between 1 and 10, so we're going to use the number 4.19. Then we multiply this by a power of 10. So we just need to work out how many times we would need to multiply 4.19 by 10 to get 419,000. To do this, I'm going to place the decimal point into the number as though it reads 4.19. Then if we multiply it by 10 once, we get 41.9, twice would be 419, a third time, a fourth time, and a fifth time. So to get to 419,000, I multiplied it by 10 5 times, so it's 10 to the power 5. For part C of this question, we need to do a calculation in standard form. But since this is paper 2, you can just type that exactly as it is into your calculator. If you do that and then press equals, you'll end up with this number here. This question says to give your answer to 3 significant figures though, so we can lose most of these digits. We just want the 6, 6, and the 4. Then we need to write this number in standard form. So as before, the first part needs to be a number between 1 and 10, so we'll need to use 6.64. Then we multiply this by a power of 10. Now this time, this number is quite a small number, so we would actually divide 6.64 by 10 a number of times. If you divided 6.64 by 10 once, it would be 0.664, and if you did it a second time, we'd get 0.0664. So we divide it twice, so it's 10 to the power negative 2. In this question, we need to write down an error interval for 1.79 that's been rounded to 2 decimal places. To do this, I like to draw out a number line. I place the number from the question in the middle, so 1.79, and then we want to write down the number that's immediately below this and immediately above this to 2 decimal places, so that'll be 1.78 and 1.80. The error interval is then formed by this section of the line here. So we want to find the number that's halfway in between 1.78 and 1.79, and that's 1.785. And also the number in between 1.79 and 1.8, and that's 1.795. These two numbers form your error interval, so it's 1.785 for the lower one and 1.795 for the upper one. In this question, we've been told the number of blue counters to the number of green counters is in the ratio 2 to 5, and we've been asked to complete this table. Well, we do already have some of the probabilities for red and yellow, 0.4 and 0.04. If we add those together, we get 0.44. Now the probabilities for all of the colours must add together to give 1. So if we do 1 subtract 0.44, we get 0.56. This means blue and green must add together to give 0.56. Now we can return to this ratio. The ratio of the number of blue to the number of green is 2 to 5, so that will also be the ratio of their probabilities. So if we write down blue to green is in the ratio 2 to 5, and then we create this table with a total column. If we add up 2 and 5, we get 7. 7 parts must represent all of the probability, which we said was 0.56. Now we need to work out what we could multiply 7 by to get 0.56. Now you can do this by doing 0.56 divided by 7 on your calculator, which is 0.08. This just means we can multiply the 2 and the 5 by 0.08 as well to work out their probabilities. 2 times 0.08 is 0.16, and 5 times 0.08 is 0.4. So the probability for blue is 0.16, and the probability for green is 0.4. For part A of this question, we need to complete a table of values. You can see we have all of the x values, but we need to work out the y values. We're going to do that by substituting the x values into this expression here. So x squared plus 2x minus 5. We'll start with when x equals negative 4. So we're just going to copy that out again, but replace the x's with negative 4. So instead of x squared, it's negative 4 squared. Instead of 2x, it's 2 lots of negative 4, and then subtract 5. You can just type this straight into your calculator, and it will give you the answer 3. So when x equals negative 4, y is equal to 3. Now they've already done negative 3 for us, so we'll move on to negative 2. So we copy out x squared plus 2x minus 5 again, but replace the x's with negative 2's. So instead of x squared, it's negative 2 squared. Then plus 2x becomes plus 2 lots of negative 2, and then subtract 5. If you type this into your calculator, you get negative 5. So if x is negative 2, y is negative 5. Then we do the same thing for 0, so it's 0 squared plus 2 lots of 0, subtract 5, which is negative 5 as well. So when x is 0, y is negative 5. In part B of the question, we need to draw the graph. To do this, we're going to take each pair of x and y values and plot them as coordinates. So the first pair is when x is negative 4 and y is 3. This is the coordinate negative 4, 3, which goes here. The next one is negative 3, negative 2, which goes here. Then we have negative 2, negative 5, negative 1, negative 6, 0, negative 5, 1, negative 2, and 2, 3. So you end up with these points here. You now want to join these with a nice smooth curve, something that looks like this. In part C of the question, we're asked to estimate the roots of this equation. Notice how this equation matches the same equation as the graph that we drew. So to find the roots of this equation, we're just looking for where this graph crosses the x-axis. You can see it crosses the x-axis in two places, here and here. So we just need to write down the values of these. The one on the left is x equals negative 3.5, and the one on the right is x equals positive 1.4. Now your answers might be slightly different to this based on how you drew your graph, but as long as you're near to these, you'll probably be fine in the exam. For the first part of this question, we need to find the class interval that contains the median. The first thing we need to know for this is the total frequency. We can get that by adding up the frequency column here. If you add up all of these numbers, you get 100. So there are 100 cars represented in this table. The median is the middle number when the numbers are in order. So if there are 100 cars, we can add 1 to 100 to get 101, and then divide this by 2 to get 50.5. This tells us that the car that's in the middle is the 50.5th one. Now that might sound weird because you can't have a 50.5th car, but we're still going to use that as though it's true in this question. To find the 50.5th car, we count down this column here until we hit 50.5. In the first group, for the cars with a speed between 30 and 40, there's only one car, so we're nowhere near the 50.5th car yet. Then if we include the second group as well, we've got 14 more cars, so 1 plus 14 is 15. We're still quite far away from 50.5. If we include the next group, however, we add 37 more cars in, so 15 plus 37 is 52. So we've now gone past the 50.5th car, so we can be sure that it's in this group. We need to write the answer as the class interval, and that was cars with speeds between 50 and 60. So that's exactly what we write down. 50 is less than s is less than or equal to 60. For the second part of the question, we need to work out an estimate for the mean speed of the cars. To do this, we're going to need to use the midpoints. For the first group, the speeds are between 30 and 40. The midpoint of 30 and 40 is 35. In the next group, it's from 40 to 50, and the midpoint is 45. And the midpoints for the next two groups are 55 and 65. We then multiply the midpoints by the frequencies. So 35 times 1, which is 35, 45 times 14, which is 630, 55 times 37, which is 2035, and 65 times 48, which is 3120. If we then add up this final column, we get a total of 5820. This represents an estimate for the total speeds of all of the cars. To find the mean, we then need to divide this by the number of cars. Well, we actually know the total number of cars because we worked it out in part A. It was 100 cars. So we just do 5820 divided by 100, which gives you 58.2. So the answer to this question is 58.2. In this question, we need to work out the length of AC. I'm going to label that one as x. This question's about trigonometry, so we're going to need to label the sides. We'll start with the hypotenuse, which is opposite the right angle. The opposite is opposite the angle given in the question, so opposite the 33, and the adjacent is the other side. In this question, you can see that we have the adjacent, we have the opposite, but we don't have the hypotenuse, so we're not going to use that in this question. We then write down SOHCAHTOA, and we're looking for the one that has the opposite and the adjacent in, and that one's tan, since it's O over A. So we can write down that tan of the angle, so tan of 33, is equal to the opposite, which was x, divided by the adjacent, which is 9. We can now solve this equation by multiplying both sides by 9. If we multiply by 9 on the left-hand side, we have 9 lots of tan 33, and if we multiply by 9 on the right-hand side, the 9s will cancel, so we just have x. We can then type this bit into our calculator. If you do, you'll find that x is equal to this number here. This question says to give your answer to 3 significant figures, so if we round it off, we get 5.84. In part B of the question, we're also using trigonometry, but this time we need to find the size of the angle. We'll start by labelling the triangle again. So the side opposite the right angle is the hypotenuse, the one opposite the angle in the question is the opposite, and the other one is the adjacent. This time we've got the hypotenuse and the opposite, but not the adjacent, so we won't need that one in this question. We write out SOHCAHTOA, and we're looking for the one with the opposite and the hypotenuse, and that one's sine. So we can write that sine of the angle, so in this case sine of x, is equal to the opposite, which is 15, over the hypotenuse, which is 18. Now to solve this one, we use inverse sine. So we write that x is equal to inverse sine of 15 over 18. You can then type this into your calculator, and you end up with x is equal to this number here. We need to give our answer correct to 1 decimal place, so if we round this off to 1 decimal place, it's 56.4. In this question, we have ABCDE, which is a pentagon, and we need to work out the size of angle DEA. Since this is a pentagon, we can work out the sum of its interior angles using this formula here, where n is the number of sides. Since a pentagon has 5 sides, we can replace n with 5, so it's 5, take away 2, times 180, which is 540. This means all of the angles in a pentagon must add up to give 540 degrees. We already know the size of 2 of the angles, the 100 and the 76 here, so we can subtract those from the 540. 540, take 76 and take 100, is 364. So the remaining 3 angles must add up to 364. Now we're told something about those 3 angles, we're told their ratio, it's 6 to 5 to 2. So if we write out this ratio of BCD, CDE and DEA, and create a total column, the ratio was 6 to 5 to 2, and the total number of parts there is 6 plus 5 plus 2, which is 13. So 13 parts must represent all of the angles, which we said added up to 364 degrees. So we just need to work out what you would multiply 13 by to get 364. So do 364 divided by 13, and you get 28. So we can just multiply the other parts of the ratio by 28 to find out their size. 6 lots of 28 is 168, 5 lots of 28 is 140, and 2 lots of 28 is 56. Now in the question we were asked for angle DEA, which we've now shown is 56 degrees, so the answer is 56. In the first part of this question we're asked to factorise. We factorised in a previous question and it meant to put it into brackets. If there's a factorised question this late in the paper, you're probably going to need to factorise into a double bracket. To factorise it, we're going to look at this number at the end. We want to think of all of the ways of multiplying 2 numbers to get 36. And we've got loads of them. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Then we look for one of these pairs to add together to give negative 15. But since it's a negative, none of these will add to give negative 15 at the moment. They're all positive numbers, so if you add them together, you'll get a positive answer. But this is because you could also multiply negative versions of these numbers together and still get positive 36. For example, negative 1 times negative 36 is positive 36. So it's one of these that we're going to need to use to get negative 15. If you add together each of these pairs, you'll find that the middle one here will add together to give negative 15. So that's the one we need. This means the brackets are x take 3 and x take 12. In the final part of this question, we need to simplify this. Here we're testing the bracket to a power law. When you have brackets like this, you can just multiply the powers. So if we multiply 4 and 5, we get 20. So the first part here is c to the power 20. In the second part, we need to multiply 5 and 4, which is also 20. So it's c to the power 20. Now we're multiplying these together, and when you multiply like this with indices, you add the powers. So we can do 20 add 20, which is 40. so it's c to the power 40, and that's the answer to the question. In this question, we're told that D is going to invest £3,200 for 5 years in a bank paying 3.5% compound interest per year. We need to work out how much money will be in D's account. So we start with the money, £3,200, and then we multiply this by the multiplier for a 3.5% increase. To work this out, we say 100% plus 3.5% will be 103.5%. Then we divide this by 100, so 103.5 divided by 100, which is 1.035. So this is the multiplier for 3.5% interest. So we multiply 3,200 by this multiplier. But we need to do it for 5 years, so we do it to the power 5. You then just type that into your calculator and you get this as the answer. Now money must be rounded off to 2 decimal places, so we're going to draw a line here, and if we check the 6 here, we need to round up. So the 9 needs to round up, but if the 9 rounds up, the 5 will also round up, so the 59 becomes 60. So it's £3,800 and 60 pence. Thank you for watching this video, I hope you found it useful. Here are some rough suggested grade boundaries, but remember we don't know the real grade boundaries until after the exams are done. Subscribe to my channel so you don't miss out on future videos, and it will help me out a lot if you like, comment or share this video with your friends.